Translations. A translation is a transformation in a plane that maps all points of a preimage to the corresponding points of the image by the same distance and in the same direction. This is the mapping given by triangle ABC maps onto triangle A prime, B prime, C prime. Shown below is the mapping given by triangle ABC maps onto triangle A prime, B prime, C prime. It's a translation. Corresponding points are equidistant and in the same direction. This means A prime equals B prime equals C prime, and these line segments are all parallel. This mapping is a translation that produces a congruent image. So line segment AB here is congruent to line segment A prime, B prime. Line segment BC is congruent to line segment B prime, C prime, and line segment AC is congruent to line segment A prime, C prime. Because they're congruent triangles, we also see that angle A is congruent to angle A prime, angle B is congruent to angle B prime, and angle C is congruent to angle C prime. Since triangle ABC maps onto triangle A prime, B prime, C prime, we know that the triangles are congruent. So far, so good. But if I'm given these two triangles, how do I prove them congruent based on using transformations? That's made possible through analytic geometry on the Cartesian plane. A grid can be superimposed over figures to allow for further inquiry. Let's come up with an explanation that predicts where any point on the triangle ABC is mapped to its corresponding point on triangle A prime, B prime, C prime. Of course, we can use the vertices of triangle ABC as representative points. With the aid of the Cartesian plane, let's describe the translation point by point. A to A prime, B to B prime, and C to C prime. To get from B to B prime, you move up 4 and to the right 9, and you arrive at B prime. Will this explain how to get from C to C prime? Yes, it will, because you would also just move up 4, 1, 2, 3, 4, and then to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And as you can see, we move up 4 to the right 9. Will this also explain how to get from A to A prime? Why, yes, it will. Once again, we move up 4 and to the right 9. We have shown that each pre-image vertex is translated to each image vertex by translating up 4 units in the positive y direction and 9 units right in the positive x direction. While strictly speaking, we need to do that for every point, not just the vertices, but we can be confident that once the endpoints coincide, so will all of the points between them. The mapping that explains this translation can be captured symbolically in the following way. 9 sub 9, 4, triangle ABC maps onto triangle A prime, B prime, C prime, where T is a function that maps point to point. Any point, x, y, on the graph of triangle ABC gets mapped to x plus 9, y plus 4. Click the Desmos icon to access an interactive website that demonstrates the mapping. Here's an exercise. Let each x-y pair in ABCD be mapped to x plus h, y plus k. This can be written in two other ways, here and here. What is h? What is k? Here's our solution. To get from C to C prime, we would move down 4 and to the right 6. So this means that h equals 6 and k equals -4. Alright, so if we have t sub -2, 5, and we have triangle DEF maps onto triangle D prime, E prime, F prime, what are the coordinates of the preimage and image vertices? Alright, so here's our preimage. D is at -2, 3. E is at -4, -3. And F is at 3, -4. Alright, so we're going to be going to the left 2 and up 5. 1, 2, 1, 2, 3, 4, 5. Here's D prime. Alright, let's do E next. So we're going to the left 2 and up 5. 1, 2, 3, 4, 5, E prime. And then F, 1, 2, 1, 2, 3, 4, 5, F prime. So we can connect those dots with lines. And we have a successful translation. So where are these points? Let's look. D is at -4, 8. E is at -6, 2. And F is at 1, 1 of the new image. Alright, so since these are all of the coordinates, it's very easy to graph the triangle of D prime, E prime, F prime. There we go, just like that. Next, we'll draw D, D prime, so from this point to this point, E, E prime, and F, F prime. And these three segments are all of the same length. Not only are the segments congruent, but they're also parallel, because translation preserves both length and direction. Write a translation rule that maps PQRS to P prime, Q prime, R prime, S prime. All right, so we go up. We'll do from P to P prime. 1, 2, 3, 4, 5. So this is 5. And then we go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this length here is 10. So the translation would be positive 10, because we do X first here, and positive 5, because we go up 5 vertically. So you could write T open bracket 10 comma 5 like this, with PQRS maps to P prime, Q prime, R prime, S prime, or you could write it like this. The translation of X to Y maps onto X plus 10, Y plus 5.